So as we talk about the theory of plate tectonics, based on what we talked about earlier this week, let's start out with what is the difference, scientifically speaking, between a hypothesis and a theory. Because this is one of the kind of unfortunate times in science where the everyday definition of theory is very different than the scientific definition of theory. So in terms of science, what's a hypothesis? What's a theory? Who wants to help us out here? Okay, what's a hypothesis? Okay, good. So a hypothesis is an educated guess. So you have some idea about a topic, educated guess. And so based on your observations, you guess what might happen. Last year in this class, we did the pond lab, and if you were in Miss US class, you did the radish lab. So based on what you knew about growing radishes, you made a hypothesis about what might make them grow best. In our class, we looked at these ponds, and based on what we'd seen, we predicted what do you think will happen to the life in the pond over time. It's an educated guess that you then test to find out if you're right or wrong. A hypothesis can be proven or disproven, but it's kind of in process. Now the problem is that in everyday kind of common culture, people say, I have a theory about why that is. They don't have a theory, they actually have a hypothesis. But I don't know, I guess it doesn't sound as good. Because in science, a theory isn't a guess or an idea or a prediction. In science, a theory is a well-tested, well-accepted idea that has been that has evidence to support it, and basically has been proven through experimentation. So some theories in science, like cell theory, do you remember cell theory from last year? All living things are made of cells. Just a theory. A theory is a big deal, right? Well, that's the problem, is that when you come up with the theory of evolution, people go, oh, it's just a theory. Well, in science, a theory is a big deal. So this year, we're going to talk about the theory of plate tectonics, but it started out as the hypothesis of continental drift. So today we're going to talk a little bit about continental drift, where it came from, why it was not well accepted at first, and that it needed some changes to become a theory. So what you will read about today, whoops, that's the wrong page. So there was this gentleman named Alfred Wegener, and he was part of the problem here. Alfred Wegener. And plate tectonics is a relatively new theory. When I was in middle school, it wasn't so much in the textbooks, but it was the idea that was being pushed, that was being accepted. So Alfred Wegener, he was a scientist. He was actually a weather scientist, but he was looking and he said, you know what's really weird about a map? That if you look at a map, it looks kind of like these things would fit together, like pieces of a puzzle. Whoa, look at that. You ever notice that? And so Wegener says, you know, this is really strange because it looks, I mean, it's not a perfect fit, but if you twist these things around a little bit, it looks like it's a big puzzle. So India here has to kind of move, though. And so he said, he proposed a hypothesis. He proposed an idea that all of the continents used to be together in this one big, giant, huge continent. And he called it Pangea, which means pan means all, Gea means earth. He said, I think everything used to be all together in one big continent. And he actually had some evidence to show that this was true. When you line up, well, first of all, there's the puzzle piece fit. I mean, that's pretty cool. And then if you line it up, the reason there's dots here and pictures of leaves is that the dots show that the rock types in these areas are very similar. There were fossils that matched here, and with the fossils they could kind of date it. There's mountain ranges that matched up, and so there were many things that suggested that indeed all of the continents were maybe once together as one big giant supercontinent. But there's just one problem. If Alfred Wegener told you that all the continents used to be all together at one time, might you have a big question about that? What would be your problem with this? Yeah, how did they separate? Very good. How could the continents possibly move? They're big, they're huge, they're solid. And Alfred Wegener could not come up with evidence or an adequate explanation as what could cause the continents to move. So even though he had evidence like, this is from the textbook here, here's some mountains, here's coal beds, which is a fossil, glacial deposits, this is a fossil of a particular plant, fossil of a particular animal, and another lizard animal thing. And so all this stuff matched up. But he had two huge things working against him. One is that he couldn't explain how a continent could move. And the second thing, he wasn't actually a geologist. He was a weather scientist. And so the geologists are like, you know what? Leave us alone. This is not your area of expertise. We don't like your ideas. Turns out he was right. But of course, as science moves so very slowly sometimes, his ideas were accepted after he died. And so here's this. We found a couple. Did anyone read ahead? Does anyone know what's causing this? Earthquakes, kind of. It turns out, yeah, yeah. It turns out that the evidence he needed was found on the ocean floor. And it does have to do with earthquakes and volcanoes, but it also has to do with inside the earth, and it has to do, oh, go ahead. Yes, the Mariana Trench is part of, that's where actually two plates are moving together. There's a really big area here in the middle of the Atlantic Ocean called the Mid-Atlantic Ridge, and this is a mountain range, and these are actually moving apart. And it turns out that the scientists, and you'll read about this later, or you'll read about this today, it's called sea floor spreading. And you can actually see, you can actually measure and document that these two are being pushed apart very, very slowly. The continents move about the speed that your fingernails grow. So it's too slow to see it. They are still moving, but in some places they're moving apart, and in some places they're crashing together, which does make things like the Marianas Trench, and it does make mountains and volcanoes and things like that. So this was discovered later with a little more technology. I do not remember where I was going with that. Oh, but the force that's causing them to move is convection currents in the mantle. Aha. So there was a reason we talked about that Monday and Tuesday. So that information about the convection currents, about the heat, about the movement, ends up being the force that moves the continents, and then that leads to this. So with that kind of preface to what you're going to read today, we'll go over this next part in a little more detail tomorrow, but the worksheets you'll work on today and beginning of tomorrow, first it talks about continental drift, this idea, this hypothesis that Alfred Wegener put forth, then seafloor spreading, which is the evidence that supported it, and then plate tectonics, which is the actual theory that we all, that scientists all believe in now. So with that, I will let you get started on today's work.